Okay, we are entering section 9.1, composite and inverse functions. Now the first thing that we're probably not familiar with is the term composite. And a composite function is basically when one function is put inside, used as an input inside of another function. And it looks like f open circle g, which is also defined as f open circle g of x, which also is equal to f of g of x. So basically, if you have f open circle g, you input the g function in place of x in the f. So this is my favorite way to write it, because this says the g function is put inside of the f. So that's what I prefer. So let's look at an example. F of x is 3x and g of x is equals 1 plus x squared. So f of x is 3x, g of x is 1 plus x squared. And now if I want to find, part A, we'll start by finding f open circle g of 5. Some people will even shorthand and say this fog of 5, like F-O-G, fog, but it's not an O, it's a tiny open circle. And this is also written as, this is the way I prefer to write it, f of g of 5. So what we'll do is we find the g function, which is 1 plus x squared, and we put a 5 in it. So we have 1 plus 5 squared. And then we have f of that. So 1 plus 5 squared is 26. F of 26. Now we go up to the f function, and so we have 3 times 26 is 78. So that's how you find f of g of 5. Now if we were to go the other direction and find g of f of 5, we start with f of 5. So we have 3 times 5, and that's what goes inside of g. So 3 times 5 is 15. And now we put g of 15. So in place of g of x, we're going to put a 15 in. 1 plus 15 squared equals, 15 squared is 225, plus 1 is 226. So you work your way inside out. So here you start on the inside, you plug the 5 into what it said, g, and then you get that number and you plug it into f. Same thing. So notice how they're not the same answer. So the order does matter. G of f or f of g, even though they're both of the same number, does not give you the same answer. Okay. So now if I have f of g of x and not a number, that's f of g of x, just like we defined it at the beginning. So g of x is 1 plus x squared. And now I want f of that. And the f function says 3x. So I have 3 times 1 plus x squared. And I can just distribute and get 3 plus 3x squared. Okay? Let's go the other direction. G of f of x. And we get g of f of x. And this is how I always automatically write it. I prefer this over this because it tells me what to start with. So I start on the inside with f of x, which is 3x, and then I put that in place of x for g, which was 1 plus x squared. So this is 1 plus f of x, which is 3x squared. 1 plus 3x squared is 9x squared, and 1 plus that is just 1 plus. So please notice that these do not give the same output. They are not the same thing. Okay, so now I'm going to give you a problem to try. Oops. And this is what you're going to show me. Part of what you're going to show me, probably. For those of you watching me on mute, there's your note. Ha ha ha. So there's your two functions. F of x is square root of x. G of x is x minus 1. I want you to find f circle g of x and g circle f of x. Pause it, take your time, go back and watch the first example over again, because you will get points for doing those two problems. Number 3. If h of x equals 7x plus 3 quantity squared, now I want you to find f and g where h of x equals f circle g of x. So again, it's f of g of x. And so I'm looking for the inside function first. Well, it looks like the inside function to me is 7x plus 3. And then what is that 7x plus 3 doing? That's what the f of x is telling us. And we are squaring it, so it's x squared. So notice if you plug them back in, if you plug 7x plus 3 into x squared, you get 7x plus 3 squared. It is not the only correct answer. Sometimes these have multiple variations, and if you thought of something different, you can have me check it if you'd like. But that's just the most common answer you'd probably give. Okay, let's just remind ourselves what the definition of a function is. It says each input has exactly one output. And different inputs can go to same output. Now think of a time where different inputs go to the same output. So I have different x's, say here and here, that go to the same y value. So that would be probably something like a parabola. And a parabola still is a function. The other key to a function is it passes a special kind of test. Do you know what that test is? It's the vertical line test. The vertical line test is when you put a vertical line on your parabola or your function of any sort, and notice that the parabola only touches the vertical line in one place at a time. Okay, so now we're going to talk about this new type of function called one-to-one. And it's a specific kind of function. And it's when different inputs have different outputs. So in the parabola case, there's all the different inputs have to have different outputs. They can't share. So a parabola is not one-to-one. And the easiest thing that I always remember about one-to-one is it passes what we're going to now call the horizontal line test. And the parabola obviously does not pass a horizontal line test, where your line is now horizontal, and here it is touching the parabola in two places at one time. Okay? The other note is if the function is one-to-one, there's another way to write one-to-one, 1:1, then its inverse is also a function. So it says then its inverse is also a function. So, let's see. Let's look at one of those. Here's the kind of questions you'll get. Is f of x equals x squared 1 to 1? Okay, well, x squared, we talked about that. That's a parabola. If it's 1 to 1, it passes a horizontal line test, does it? There's a horizontal line where it does not pass. There's 2 instances. So, no, it's not 1 to 1. And what does that mean? It means no inverse exists. Because if it is 1 to 1, then the inverse is a function and it exists. Here, it's not. You could also be given a picture. And we'll get into what these graphs are, logs and exponents. And does this pass the horizontal line test? And this is slowly and slowly increasing. My pen is just a little too fat to show that, but it is increasing gradually as we go. So yes, and it means the inverse does exist. Whoops. Okay. Here are your steps to find the inverse. I think these might be one of my favorite sets of steps in algebra. First thing we have to check is it must be 1 to 1. Just like we answered those previous questions. If it's not, there's no inverse. Here's the steps. Replace f of x with y. So, and you know that, f of x equals y, so anywhere you see f of x, just change it to y. So you have an equation with x and y. Switch, this is the key, x and y. Swap places with them and solve for y. And then the y really was f of x, so now it's the inverse. So we replace y with f inverse of x. And that's the notation. And note, that -1 is not an exponent. That does not really look like the word exponent, but write that. Not an exponent. It is not 1 over f. Like if you saw x to the -1, you'd say 1 over x. It is an inverse symbol. But granted, they look like the same symbol, but that's not what that says. Okay. Number 6. Determine if function is 1 to 1. If so, find the inverse. F inverse x. That's how that's read. Okay? So f of x equals x plus 2. So what does that look like? You should quickly be able to say it's a line. Looks something like that. Yes, it passes the horizontal line test. Okay. So now for our steps. Step 1, replace f of x with y. Step 2, switch x and y. Step 3, solve for y. So we're going to subtract the 2 over, so we get y equals x minus 2. And step 4, replace y with f inverse of x. There's the inverse. Not all that difficult. Actually, that's why I kind of like these. F of x equals 2x minus 3. Again, switch them. Or check to see if it's an if it's 1 to 1. And yes, it is because it's just another line. So start your steps. There's step 1. You can finish and you can show me your final answer, which should look something like this, and you tell me what goes in that little box. And the last thing I want you to do is graph f of x equals 2x minus 3 and f inverse of x equals x plus 3 over 2. Graph both of those on same graph and tell me one or two things about them that's the same, what's similar, maybe what kind of relationship that they have. And we will stop there and we'll start notes there on Friday. These are due Friday at the beginning of class.